slate to be presenting today, Deb and the rest of the team from the Cancer Domain. So I'm going to jump straight into the announcements while we're still waiting for a few more people to join. So just to remind everyone, our next meeting, which is going to be held at the end of this month on April 24th, is going to be another one of our themed sessions around variant curation this time. So we're asking everyone to please, if you have any questions around variant curation, to please submit them through that Google form that we've created there, and we'll put the link for that. Oh, Kazan's already done it. That link for that is in the chat. Obviously, there will be the opportunity to ask questions live throughout the call as well. But if you have questions in advance, it really helps us with planning to get a bit of a sense of what people are wanting to know about right now, if you can be submitting those questions in advance. And the other thing I want to mention, and I'm not sure if Courtney is on, just it doesn't look like she is, but that's okay. I'll quickly put in a plug that ClinGen also has a separate survey at the moment around the use of AI and machine learning in biocuration. People's responses to this are completely anonymous, but I'm asking as many people within the ClinGen ecosystem as possible to please fill this survey out by the end of April, because we're going to be using it to help develop some policies and procedures around the use of these technologies in curations, and obviously with the goal of helping to make them more efficient. So there's 2 surveys there that we're asking you to please fill out in the next couple of weeks. So thank you so much for that. I know everyone's volunteering their time, but these surveys really do help us. But with that, if there's not any other general announcements, I am going to introduce our speakers for today. So we have Deborah, Ritter, Megan Frone, Pam Robertson, and Alicia Gomes, all here today on behalf of the Hereditary Cancer Clinical Domain to give us an overview of what's been happening in that space recently.
Great. All right. I will share. Right, I think I'll keep it in this mode if that's okay for everyone, or should I go to the the slide share?
Let's
see.
I wonder if
I do, let me just
you
try
do
it
the slide
quickly.
share just so it's a little bigger, particularly if you record this and it goes on YouTube, and then it ends up very small in that view.
No worries. So is that's a good view?
That's looking fine to me.
Great. All right, then
Perfect.
I'll get us started out. So I'm Deb Ritter. I am part of the BCM Stanford team at ClinGen, and I'll do an overview of the Hereditary Cancer Clinical Domain. Then we have additional coordinators, Megan Frone, Alicia Gomes from two of our VCEPs in the Hereditary Cancer Clinical Domain, and Megan will also be presenting on some updates from behalf of the DICER VCEP. And then Pamela Robertson will give us an overview of the hereditary cancer gene curation, and as well, one of our new GCEPs within this clinical domain that focuses on childhood, adolescent, and young adult cancers. So we'll do a brief outline, and then I wanted to talk through, what are clinical domains within ClinGen, because I realize sometimes biocurators aren't necessarily aware of kind of the larger efforts of clinical domains. I think someone needs to go on silent. And then we'll talk about a brief overview of the hereditary cancer clinical domain, particularly people and participants, and how have we prioritized the development of VCEPs and GCEPs. And I want to note that we are in the process of developing a new VCEP. So it'll be tuberous sclerosis, TSC1 and TSC2 gene. So if you're interested in biocuration, please, for those particular cancers, please reach out. And then we'll talk about hereditary cancer domain, the variants, and particularly specifications. So I wanted to talk really about accessing some additional information about variants, and then as well accessing prior versions of specifications, because I think those 2 things are pretty relevant for biocuration activities. Then we'll briefly talk about some of the education and outreach activities. We'll have an update from TP53 DICER and neurofibromatosis and schwannomatosis. Then we switch over to gene curation, and we'll do an overview on gene curation, as well as a lot of some of the work that's been done in recurating a large set of genes and disease naming, and introduction with this new hereditary cancer Kaya GCEP. So not a lot planned. So this is an overview of the 16 clinical domain working groups within ClinGen and the gene curation and variant curation groups that are within those clinical domains. So, and I also mapped this here as well to the liaison main ClinGen grant, so Broad-Geisinger, UNC, or BCM Stanford. So clinical domains are organized as in terms of sort of priority areas for the disease, and they really help to guide what types of GCEPs or what types of VCEPs, what particular focus they have within that sort of priority area. That's sort of the best way I can describe it. However, there's a great description in a paper by Laura Milko et al. From a couple of years ago that describes really the structure of a clinical domain, having co-chairs, a PI liaison and coordinator, and then an expert committee within the clinical domain that then also contains any of the GCEPs and VCEPs and the members within there. So the hereditary cancer clinical domain was one of the first early clinical domains of ClinGen and had some of the early VCEPs. So CDH1 and PTEN, for instance, they published specifications already in 2018. So many of these VCEPs are also on subsequent versions, major versions of specifications coming out. We were recently looking in our annual updates that we have over 500 unique members across all of the different participants within the clinical domain. We have 12 VCEPs covering 51 genes. 9 of those are approved and published VCEPs, so they have at least one gene that's approved and published. And it's for 15 of those genes are the published specifications, and we have 2 GCEPs now. So this just puts some faces to the names here. We have our co-chairs are Sharon Plon. She's the contact PI for the BCM Stanford grant. Doug Stewart, who is an investigator at the National Cancer Institute. And then I listed here our coordinators. These are coordinators that are funded through the BCM Stanford grant. Obviously, we have many other coordinators that are coordinating the GCEPs and VCEPs. I don't have all of them listed here, but I wanted you to make sure that you have the names, faces, contacts if you need to reach out to us for any questions you might have. If you have curation in a different disease that might be related to a cancer phenotype, or you want some extra input on a cancer phenotype associated with a disease that we might not be curating, we are the people to reach out to. In particular, I want to also note that Sahaya Bryant has recently joined us in January as a research assistant. And so you'll be seeing her on many of these calls coming up as well. So our co-chairs then run the executive committee and then as well the entire hereditary cancer domain. So our executive committee has the chairs and coordinators of the VCEPs and GCEPs, plus additional invited cancer experts to that committee. And then we also have for our full domain, we have all chairs, coordinators, GCEP, VCEP experts, members, and any annotators that we might have as well within the different groups. So this is an overview of the different VCEPs that we have on the left-hand side and the 2 GCEPs that we have. So again, we had some of the early VCEPs, CDH1, PTEN, TP53, myeloid malignancy. And I do want to note that CDH1 was initially called CDH1 VCEP and has now changed the name to gastric cancer and is adding in CTNN1A. So in particular, this was, if you have any questions about changing names or the process of name changing for VCEPs, you can reach out to us going through the process currently. Myeloid malignancy as well, dicer and microRNA processing genes, hereditary cancer, breast, ovarian, and pancreatic, Enigma, BRCA1 and 2, VHL, which I'm the coordinator for, Insight, hereditary colorectal cancer, and neurofibromatosis, schwannomatosis, which we'll have an overview of as well. A new VCEPs that we have started, relatively new, is endocrine cancer tumor predisposition. So this one covers many of these ACMG secondary findings genes. Ocular oncology is a newer VCEP, and again, we are developing TSC1 and 2. And then this lists the genes that we have specifications published for. And as well, we have our two hereditary cancer GCEPs. So one is a core GCEP. It was initially started, and Pam will go through some of this later on, but it was initially started with two GCEPs, one focused on colorectal cancer and one on breast ovarian cancer. And then we've gone through a large recuration effort as those two groups have merged into this core GCEP. And we have a next set coming up. I believe it's in the pancreatitis area. And then as well, the recently developed Kaya GCEP. This is an overview of secondary findings genes and of the coverage for the hereditary cancer domain VCEPs of these secondary findings genes. So I bring this up just to say that this is sort of the kind of guiding vision for the hereditary cancer domain, is to have coverage across these secondary findings genes, because if you are not familiar with secondary findings genes, they are sort of this opportunistic screening. When you're sequenced for a particular gene or disease, there is a set of a minimal set of genes that can be returned where you might have an opportunity to reduce morbidity or mortality if you have the knowledge of this gene. So oftentimes these are more actionable genes, we might say. And you can, when you're sequenced, you can have a choice whether or not you want those results returned. So that sort of was the principle around which a lot of the early development has been organized in genes that we want to have covered. So you can notice we have most of these in a VCEP currently, except for Wilms tumor. So Wilms tumor currently, WT1 gene. We don't have anything planned yet, but if you're interested, please do reach out. So this is an overview just of variant pathogenicity statistics in ClinGen in general. So there's total of, at the time we checked in March, 80 VCEPs that were in various stages of approval, with 35 VCEPs that have complete approval and about 9,700 variant pathogenicity curations. So hereditary cancer from those has a total of about 2,500 out of those. So we're about 25% of all of the ClinGen variants. And you can see here, myeloid malignancy is about half of those for the hereditary cancer clinical domain. So I wanted to point out how to access some of the additional information about variants, because I think that's probably really relevant for biocurators on the call. So you can access the eRepo, which is the ClinGen evidence repository, through ClinVar. So once the variants are in ClinVar, if you go to a variant within ClinVar, you can see other databases and then click on the eRepo link, and it will also access eRepo variants through the ClinGen allele registry linked data section. So this is a new section at the top. You'll be seeing some more development on this for the ClinGen allele registry as we're adding in the linked data into this interface. So you can click here for to go to the evidence repository from the allele registry. You can also click to go to ClinVar from the allele registry as well. And why would you click out to ClinVar? Click out to the eRepo from ClinVar or from these other resources. And one is to say that in the explanation box for a lot of variant curations, there is additional information about that variant. So this is particularly relevant to biocurators that may be, adding information into these explanation boxes in the interface, and then summarizing that. So you have a bit of a choice between, like, when you summarize, of how much do you include and how much do you make the summary kind of more cohesive and consistent across that. So at times I have found that clicking back to look at these explanations really gives a bit more detail into the curation itself. So I want to give one concrete example of that here, where in the evidence repository, so in ClinVar, you would see the, and then you can click out and you can go into here. So in this case, it says that this is a canonical splice variant that meets PVS1 strong in this case. And then if you go into here, you can see in the explanation exactly the criteria that was used for it to be able to meet PVS strong. So again, it's just this additional supporting information if that's helpful to your understanding of the variant, and especially to your understanding for those of you who are newly curating what you should be looking for, how they came to that conclusion for the PVS1 strong, for instance. I also wanted to highlight here the expert panel specifications, and particularly how you can access prior specifications, as that can also inform the curation process. So you can use the criteria specification registry, the CSpec registry, to access all of the variant specifications within ClinGen. And as I said, the hereditary cancer VCEPs are some of the older VCEPs within ClinGen. So that means they've had more time then to also go through and make multiple versions of their criteria specifications. So you can see some of them, B10 and CDH1, for instance, are on version 3. So each time there's a sort of major version change, we change this first number, and anytime there are more minor version changes, it's this second number. So what are some of the reasons you might change or update your specifications? One, for instance, was the use of converting to points. So using points either for the full curation or using points only for combining information in case of conflicting information. That's one of the reasons groups have updated. Another might be large-scale functional data. For instance, you're incorporating an assay that didn't exist in the first version of specifications. So I wanted to point out how to access these prior versions and why you might do so. So one is an example here with CDH1. In the criteria specification registry, you can go to this little box here on the side, and if you hover over, it says what you'll be clicking out to. So this would be all of the SVI approved versions. Then I'll take you to a page here that has these multiple versions as well, which you can click on. So particularly when you do click on that one, you'll see these release notes, and the release notes talks about major changes for these versions. So if you are a biocurator working with a VCEP that has multiple versions, I would suggest just going back through and taking a look in the criteria specification registry about what are the release notes associated with that? What were some of the major changes going on, just to be informed about it. For instance, one of the changes here was a major change for CDH1 in version 3 about using the Bayesian point system when there was conflicting evidence that might otherwise result in a VUS. So that's important to know as you're curating on in any version moving forward, is that this change was implemented from then forward within CDH1 to curate using and to convert to the Bayesian point system only under the case of conflicting evidence. That's just an example of why you might want to go back through and look at some of the change reasons. All right, so I'll talk briefly about some of the education and outreach efforts that we have going on within the hereditary cancer clinical domain. So we have several outreach efforts going on to disease support groups and also working with foundations for funding, community engagement, and education. We've worked for several years providing internship and educational opportunities in genetics, particularly with a program, Saturday Morning Science, that has summer interns and as well has educational efforts in genetics from 6th graders up to 12th grade. And then our undergraduate and post-baccalaureate training programs with internship programs, as well as a bioinformatics boot camp. And then separately, we've had several efforts to work on international outreach through VCI training. So using VCI through using training in the variant curation interface, particularly with some genetics organizations. And so we are working on developing this into really a set of materials that we can put out that that others can use to have a similar variant curation workshops. This last effort I'll talk about is an ongoing effort, which we're getting additional data on recently, but we've been engaging the patient community in ClinGen's work using Facebook. So initially, we had looked at hereditary cancer groups and Facebook groups that have a topic similar to either the genes or the conditions that we have within the hereditary cancer clinical domain. And from that work, we found that there were a number of Facebook groups, some of them interested in genetics, some of them not interested in genetics. And that's part of what we did, was trying to understand what these groups will would be interested in terms of genetic information. And so this was really founded based on personal experience, my own personal experience of using Facebook for my son's rare disease. And so finding really a community and an informational community through that rare disease group. So then we've created a short questionnaire for which we had an IRB exemption to be able to give that to administrators and moderators of these Facebook groups, asking particularly what educational materials would they be interested in. And the purpose of that is to communicate the work of ClinGen to these Facebook groups through providing them with these educational materials. So if you are on Facebook and if you have an interest, please find the Hereditary Cancer ClinGen Clinical Domain page. Sahaya, who has joined us, will be running this page and posting some content particularly related to hereditary cancer. We do have a main ClinGen Facebook page as well, so you can join both of those pages, but we'll be focusing on the Hereditary Cancer Clinical Domain page and adding educational content on that page as well coming up. All right, so I think that concludes kind of a brief overview for the hereditary cancer domain and some of the educational efforts we have. And I think I'll hand it over now to Megan. I'll keep running the slides, but Megan, I'll let you come on to tell us about TP53 and DICER1.
Sure. You want to go to the next slide?
Yeah, there we are.
Okay, thanks. So I'm Megan Frone. I'm a genetic counselor at the National Cancer Institute. And part of my duties is to be involved with VCEPs or with ClinGen as a whole. So I am the coordinator for the TP53 VCEP, and then I biocurate for the DICER1 VCEP. And Jessica Hatton, who's another genetic counselor here, she is out on maternity leave, but she is actually the coordinator for the DICER1 VCEP. So I'll be giving that update as well. And Deb had just asked to give a brief update with just some details particular to biocurators. So starting with TP53, we just underwent one of our first major revisions. So we are now on our version 2 that was approved in August 2024. So in our first original V1, we excluded 9 of the original ACMG AMP criteria, and we modified 19 criteria. And then in this new version 2 version, we modified all 19 again with major and minor revisions. And we added a previously excluded code. So we actually added PP4 code, and we have kind of a unique use case for it that we worked really closely with the SBI. So we actually do PP4, which is kind of traditionally a tumor code, and we actually do this for low variant allele fraction variants. And this was based off of work that several of our expert members did that show that these CHIP variants are actually kind of an in vivo functional assay for variant pathogenicity. So we were able to use variant allele fraction data to score PP4. And a lot of the work that we've done within the VCEP is quantitative-based work on likelihood ratios based off of Bayes' theorem. So we're able to kind of incorporate this nicely into the framework that we know we're moving towards with ACMG4. We also, in the version 2, the other major thing we did was move to a Bayes-based points total a la Taftigan, when before we were using just regular combining code criteria. So that publication is submitted to Genome Medicine. We actually are resubmitting our revisions probably this week or next week. So we hope to have that published soon. The rules are live in the CSPEC and we're utilizing them. We presented the new rules at the Lee-Fermini Syndrome Annual International Symposium back this fall in October. And we have 7 biocurators within the VCEP. And we have 125 variants currently curated in ClinVar in the eRepo. And that number hasn't moved for a bit, both because of our version 2 rule update. We were paused for curation during that time. And then also we then prioritized doing a major curation of all the variants that were due for updates with our version 2 rules. So that final batch is being submitted I'll probably click submit this Friday. And then we have our first prospective batch of brand new variants with the version 2 rules that are currently being curated by our curators as I speak. And we'll be moving forward with that. And this year in the ClinGen award ceremony, we won top 3 most cited ClinGen expert panel publication for our original specifications paper. And then if you want to go to Dicer 1. So Dicer 1, so that VCEP, we are just in our continuing of our sustained curation, including the recuration of our 2-year-old VUS and LP variants. So this is the first time as a VCEP that we're going through recuration and updating of our variants. It's going smoothly. We also have 7 biocurators for this VCEP, and we have about 143 variants in because we've been able to crank through them without getting mired in a version 2 update quite yet. And the guidelines, this is a little bit more of a newer VCEP. So TP53, its original specifications came out in about 2019, I want to say. So this one, the guidelines were published in 2023. And we just found, we're informed that we were the top 10 most cited human mutation paper in 2023 for that specifications guidelines.
That's great.
My quick updates.
All right, well, thank you. All right, I'll turn it over to Alicia for updating on neurofibromatosis and schwannomatosis.
Thank you so much. Hi, everybody. My name is Alicia Gomes, and as mentioned, I'll be giving you an overview of the NF and schwannomatosis VCEP. So our chairs are Dr. Scott Plotkin and Elizabeth Castellanos. We have both a clinician and a geneticist as our chairs because, as you will see, for our group, we have quite a bit of nuance associated to the differences in the neurological specifications for these disorders. So we have quite a number of physicians on our VCEP as well. I am the coordinator, and we are representing actually 5 genes: NF1 associated with neurofibromatosis type 1, SPRED1 associated with Leigh syndrome, and then NF2, SMARCB1, and LZTR1 are all genes related to schwannomatosis. So for each of these different genes, we are at different processes as a VCEP. We have made the most progress thus far with NF1. We are in step 3, meaning that we have started and are nearing the end of our pilot for NF1. We are in the beginning stages of our pilot for SPRED1, and we are still in the rule development process for NF2, SMARCB1, and LZTR1. As Deb had mentioned, we have been awarded our U24 grant associated with our work for all of these genes. And we have been focusing on kind of getting the community ready to appreciate this rule development at the most important meetings associated with NF1 and schwannomatosis. And so we've presented at the Children's Tumor Foundation meetings for the past couple of years. Next slide, please. So these are just a review of our current processes. We began our NF1 pilot back in 2022 and decided to do 40 variants because this is such a large gene. And we are currently double checking, tidying things up with the anticipation that we will be submitting all of our pilot variants and moving into the step 4 process this year. So we will be working on our manuscript once we get this process going. For SPRED1, we are moving into the pilot phase. So we actually just divvied out our pilot variants for SPRED1. This is a much smaller pilot because the gene is much smaller than an NF1 gene. So we're hoping that this process will not take as long as it did for NF1. For NF2, SMARCB1, and LZTR1, we have begun working on the rules for these genes, and we are actually developing these rules simultaneously because there are a lot of things that are common between these genes and how they present in schwannomatosis-related disease, but then there are some things that are unique. And so we are trying to ensure that we're appropriately being consistent by working on the rule development for all three of these genes simultaneously. We are also working with ClinGen and some other individuals about the Mondo codes, especially associated with SMARCB1, as this gene is also related to rhabdoid tumor predisposition syndrome. And there are a couple of variants, and I do mean a very small handful, where you can see individuals in one family presenting with both schwannoma related features as well as rhabdoid tumors. However, there are some publications that do specify variant types that are more specific to schwannomatosis versus rhabdoid tumors. So we are currently in discussions about how to either envelop rhabdoid tumor predisposition syndrome into what we're working on for SMARCB1 versus splitting schwannomatosis out. So hopefully more to come with that soon. Next slide, please. So these are just our overall goals. We hope to have a manuscript in development very soon for NF1. Because typically when individuals are ordering testing for NF1, spread one is included. Our goal is actually to create a joint publication that includes both the specifications for NF1 and spread one, especially since spread one is in many cases an exclusionary. After excluding NF1, you can then make a diagnosis of spread one or Legius syndrome. And so we are considering the scenario of including both of these in our publication together. So this is what we're currently working on and have a goal of having something ready for submission in early 2026. And then, of course, we're still in the early phases of the schwannomatosis related genes, so more to come. And we are looking for biocurators as we are starting our spread one pilot, as well as gearing up as we continue to work through the schwannomatosis related genes. So we do have 10 biocurators currently, but as we are working through 5 genes, we are actively interested in including more individuals, but it has been at different times based on where we are in developing our pilots for these genes. So this was just my quick updates for NF1 and schwannomatosis. If you have any questions, just let me know.
Great, thank you so much. So I think we'll have questions at the end. So I will hand it over to Pam. And Pam, are you okay to screen share? If I stop screen sharing, then you can. That way you don't have to say next slide.
Okay, we'll give it a test.
Okay, let me stop sharing.
All right, how's that?
Yep, that's great.
Okay. Hi, everyone. So I'm Pamela Robertson. I'm a genomics specialist and senior biocurator for ClinGen, working at the Broad Institute of MIT and Harvard at Boston. So I will be presenting the first GCEP on Jasmine's behalf because she couldn't make it today. And so this will be on the hereditary cancer GCEP in particular. Okay, so if we look at the membership for this GCEP, the chair is Sharon Plon, and listed here are the individuals that are part of the leadership for this GCEP. Jasmine is their coordinator, and they have 9 biocurators currently in this group. So with the hereditary cancer GCEP, they have published 157 genes, which makes them the 4th largest GCEP in terms of number of published gene disease relationships. And you can see here this diagram that demonstrates that more than 100 of them are actually definitive, which is the highest classification for gene curation. And then the rest are distributed between the moderate, limited, disputed, and refuted classes. And Jasmine's included a QR code here that you can scan that will take you to ClinGen's page of summary statistics for all their activities. So there's about a decade's worth of history for the hereditary cancer GCEPs, I should say. So starting in 2015 was the formation of the breast ovarian cancer GCEP and colon cancer GCEP, who curated diseases that fell within their scope. And then in 2018, 2 papers came out from those 2 GCEPs. And at the same time, the hereditary cancer GCEP was formed. So their initial goal at the time was to focus on a Nature publication that had come out back in 2014, basically listing more than 100 genes associated with cancer predisposition. So it's a pretty big paper. And by 2021, the hereditary cancer GCEP had completed all the curations for the genes in this paper. So in 2022, the breast, ovarian, and colon cancer GCEPs actually finished up their work and became inactive. And since then, recuration efforts have been taken over by the hereditary cancer GCEP. So in 2024, a manuscript has started being drafted to detail the efforts of recuration from the breast, ovarian, and colon cancer GCEPs being done by the hereditary cancer GCEP. And also, as Deb mentioned at the start, the pancreatic cancer genes have been added to the scope of the GCEP. So to discuss the recuration a little bit more, so when these gene curations were originally done by these 2 inactive GCEPs now, they were done back then on Excel spreadsheets. And so this was what they called Gene Express, and using old versions of the SOP. So now it's very fancy. We have a online interface, the gene curation interface, or GCI for short, is how we enter our curations, and that's able to speak to the ClinGen website. So a lot has changed since then, including the SOP versions, where we're now up to version 11. One thing Jasmine put here as a note, that even though these curations were done at least 5 to 6 years ago, many of them were actually classified as definitive or refuted. And so following ClinGen's guidance, these gene-disease relationships don't actually require recuration. Some further notes on the recuration efforts by the hereditary cancer GCEP is that all gene curations done at the time were based on the latest SOP version. As I mentioned, we're now up to version 11. They recruited these genes based on data that was present in the original curations using the latest SOP, and then also newer evidence that has been published in that time. Pre-curation, which I'll talk a little bit more in the Kaya GCEP. So lumping and splitting was performed for all these curations and added into the GCI. And so all this detailed information is publicly accessible on the ClinGen website. So some more about the recuration and the status and what they found. So they reevaluated 105 gene disease pairs that were curated from these older GCEPs. For the breast ovarian cancer, 58 genes were evaluated, with 20 of the gene disease pairs maintaining their previous classifications. Whereas for the colon cancer and polyposis, 42 gene disease pairs were curated, with 22 maintaining their previous classifications and 20 of them being updated. 12 previously limited genes were retired due to a lack of new evidence. 4 were upgraded to definitive based on new genetic and experimental evidence. 3 of these were downgraded, and the naming of lots of these gene disease pairs have actually been updated based on ClinGen's recommendation for dyadic disease naming, based on a publication that actually came out last year from ClinGen's Disease Naming Advisory Committee. So to talk about that a little bit and just to provide more context for those on the call who may not know too much about dyadic disease naming. So this is referring to curated monogenic disease entities where the disease name should have the genetic component, so the gene responsible, and tied that to the relevant disease phenotype. It's not necessary to include the inheritance pattern in the disease name. And ClinGen discourages the use of terms like familial or hereditary in their phenotypic label, since by definition, monogenic diseases have the implication of being hereditary by nature. So this is a table from that publication, and the PMIDs you can see below. And so with the dyadic gene phenotype naming approach, there's two formats that you can take. And there's also an alphanumeric approach, which, for example, Omen utilizes. So if we focus on these two, the hereditary cancer GCEP has been using format 1, where they have the gene that they are curating, related, and then the phenotypic descriptor. And Jasmine's included an example to illustrate the challenges in some of the work that the hereditary cancer GCEP has been going through. So she used the example of the RAD51D gene, which in Omen is associated with breast ovarian cancer, familial susceptibility, and then you can see there's a number 4 at the end there. And then this column here is showing the original Mondo entities associated with RAD51D and what the ClinGen, so this gene was originally looked at by the breast ovarian ClinGen GCEP back in 2017. And so when they looked at it back then, I'll just point to down here, they had 2 split curations. So they had a definitive curation for familial ovarian cancer. And then they had a second curation, which was limited for hereditary breast carcinoma. And so as an update to the Mondo term base compared to what was previously in Mondo, so using the dyadic disease name, it's now RAD51D related cancer predisposition and the hereditary cancer GCEP. So they did this and lumped the 2 previous disease assertions together to fall under this. And then gave this definition here of germline variation in RAD51D, conferring an AD predisposition to tumor formation, and then listed some relevant cancers that would fall underneath that. Okay, so that's the overview that Jasmine's provided for the hereditary cancer GCEP. So I'll now move on to talking about the Kaya GCEP, which doesn't have anywhere near as long a history as the hereditary cancer GCEP, in that we started officially in the middle of last year. And so I like to think of it now as we're entering our toddler phase, where the experts and biocurators have been trained up and are really familiar with ClinGen's processes for gene curation, pre-curation, and disease naming. And so now we're really getting into the swing of things. Okay. So the Kaya GCEP is short for the Childhood, Adolescent, and Young Adult Cancer Predisposition GCEP. These are our 3 co-chairs here. So we have Naomi Fuentes-Bolanos from Australia, Chris Porter from the US, and Anita Villani from Canada. The coordinators are myself and Kelly Paris over at the Broad in Boston. We're a pretty large group. So we have 58 members in total currently. 37 of them are gene disease experts and 21 are biocurators. And in terms of our monthly attendance, it's pretty good, where we have 36 members on average who attend our calls. And one thing that I really wanted to highlight was the international scope of this GCEP. So this figure here is based on a survey we did about a year ago now of members in the group, including their country of origin in gray and their current affiliation in black. And so we have 6 different countries with members showing up to our calls, and the countries are listed here. So the States, Australia, Brazil, Canada, Germany, and England, resulting in 10 different time zones. And so as you can imagine, there's no Goldilocks time that works. It's 2 a.m. somewhere, whatever time you pick, really. And so whilst we have a lot of online discussion, we also really utilize offline polling so that members who want to attend our calls but can't can still participate and provide input. Okay, so I'll just provide some quick background into the formation of our gene list as well. we're obviously very cognizant of the cancer GCEPs prior to us and the gene disease relationships that they had already curated. And so listed here is a few of the different things that we did. And so, for example, looking at the right, Chris took a look at the cancer predisposition gene lists from 3 of the academic centers of the Kaya co-chairs. So we've got Sick Kids in Canada, Children's Cancer Institute in Australia, and Children's Healthcare Atlanta in the US. And so whilst there was a lot of overlap between the gene lists, there are about 85 genes that were seen only in a single panel. And then similarly, looking at a few commercial groups, a similar trend where there's overlap, but also some genes that are unique to a single panel. And so we wanted to take a look at these and see which ones hadn't been curated and so really should be put on our gene list and part of our scope. We also looked at other resources such as OMEN, GenCC, and EviQ, which is an Australian-based resource with a lot of information for cancer professionals, such as treatment recommendations and gene disease information. And then, of course, the literature as well. So this gave us a list of 128 genes, with 72 of them associated with hematological malignancies and bone marrow failure syndromes, and 56 associated with CNS and solid tumors. And so we found with a slight enrichment towards the more hematological malignancies, we decided to tackle these first. However, they are notoriously complex. So we did, with our membership, have the intention of making sure that we had enough individuals that had experience in that field and could really advise and speak to the diseases we were curating for. So I'm just going to give a quick summary of some of our results, starting off with pre-curation, which we started our first one in August last year. What I have here is just showing the lumping and splitting from Taxon et al. I thought this would be just helpful to show for anyone on the call who's maybe more familiar with VCEPs and variant curation, and less so with GCEPs and gene curation. And so this is a preliminary step that we do before standard gene curation, where we're asking the question, have there been multiple disease assertions associated with this gene? Yes or no? Are there differences in the molecular mechanism? Is there a difference in a phenotypic pattern? And is there differences in the inheritance pattern? And so if you're leaning towards more yeses to those questions, then that favors keeping the disease entities as separate, distinct entities that should be curated. If you're getting more no's towards that, then that leans towards lumping the disease assertions under a broader entity. So based on that, we've looked at 9 genes, which were associated with 25 disease assertions. 17 of these were lumped and consolidated, forming 6 new gene disease relationships, or GDRs. Going back to the 25 disease assertions, 8 of these were split off as distinct entities, and then we got another 2 from 2 other GCEPs that thought it was more appropriate for us to curate those the gene disease relationship or the disease assertions. So we had 10 there. So 9 of these were pushed onto Kaya. 1 was given to another GCEP that was more appropriate. And so in total for the Kaya GCEP, just from 9 genes, we ended up with 15 gene disease relationships that we now need to curate. And I guess I just want to highlight that that's why it's really important to do that pre-curation process, because it's not necessarily a 1-to-1 ratio. And then in terms of the overall curation summary, so we've done 12 standard curations, and about a half of them have been definitive, 2 of them have been moderate, 3 limited, and 1 refuted. When looking at the mode of inheritance, it's almost 50-50 between autosomal dominant and recessive. And in terms of the molecular mechanism, we've done more loss of function, but we have looked at a couple that are gain of function and 2 that were uncertain because there just wasn't enough information to ascertain that. And so I'll finish off with our plans for 2025, where our focus in the first year was to really familiarize the GCEP with ClinGen and gene curation. And as we enter the second year, we're planning to continue to work through our hematological malignancies list, and our U24 resubmission that we're working on as well. We will continue on collaborations with ClinGen, GCEPs, and VCEPs. And just while I'm thinking of it, I should point out that with our curations, that not all of them have been published on the ClinGen website yet, just as we're waiting on the Mondo terms to be finalized through Mondo, and then they should all be published on the website in case anyone's already gone ahead and had a look. So as I mentioned, continued collaboration with ClinGen GCEPs and VCEPs, which is illustrated in this table here, showing curations that have been split off and handled by us, or will be handled by us, secondary contributions with different GCEPs, and also from a variant curation perspective, the myeloid malignancies VCEP planning to start working on specifications for SAMD9 and SAMD9L. But before they can do that, the genes do need to be curated to determine what classification the gene-disease relationships receive. And so we looked at three. Two of them were definitive, one was limited. And so again, based on recommendations from ACMG and from ClinGen as well, variant specifications shouldn't be made for limited GDR. And then to finish off, we're also prioritizing challenging GDRs that have been seen in labs. And so we have a few members from the Zero Childhood Cancer team in Australia, where I used to work before ClinGen. And Naomi, our co-chair, is a part of that group. And so they're helping us with this effort as well. So I'll finish off on the acknowledgement slide showing the ClinGen community as a whole, where a lot of what we do is aided by the work of the volunteers. It wouldn't be possible without them. With over 3,000 members all around the world, 69 countries represented. And then also, of course, acknowledging the Baylor and Stanford teams and their PIs who oversee the work of the Hereditary Cancer Clinical Domain. So I'll leave it at that for discussion and questions.
Great, thank you. Yes, if anyone has any questions to ask about, from the beginning to this, I did put a question in the chat just to start out with, is asking about creating the disease entity and whether or not, so I know for the somatic cancer side, they have worked with disease ontology instead of Mondo. And I think disease ontology had created or had an effort to create some disease ontology terms specific for pediatric cancers. So I'm wondering your thoughts on that for creating that entity specific for pediatric or childhood cancers versus just the cancer, and then having a qualifier of that this was curated for this age group.
Yeah, so we've had a bit of discussion on this, and what we've decided on, based on some feedback as well, from Sharon, for example, is that so our gene list has been intentionally enriched for diseases that skew towards pediatric populations. And so what that means is that that's our focus, as our name implies, but we don't exclude in our curations adults that have the variant, a variant in the gene that we're curating for the disease. So, we haven't come across this yet, but in the instance where, let's say, we were to curate for a higher proportion of adults than children in a certain GDR, then we would probably make a note of that in the evidence summary, just so that anyone looking up at the curation could see that. But I didn't know that about the somatic group, so that was interesting to know their approach there and how they were handling that.
Yeah. But again, it's with disease ontology, so it's a whole different ontology set, which is going to be, I don't know exactly the relation between Mondo and disease ontology. If there is, I'm thinking there's probably not a one-to-one in between those. So, but yeah.
Any other questions? If not, I do have one other quick one again for you, Pam. So I'm sorry, but not specifically about cancer, but I wonder if you can comment at all to some of the scheduling challenges. Like you mentioned that you've got curators from however many institutions and time zones represented. And so I know that's a challenge faced commonly across many expert panels. And so do you have tips and tricks that you've learned, or like maybe perhaps you could speak a little bit to the offline polling that you do and how that works.
Yeah, so it was certainly a challenge at the start, and I recognize this is a common challenge for a lot of expert panels in ClinGen, where we are intentional about being international in scope, and it just came down to a majority rules approach. So we did send off an initial poll to the group to fill in. We gave a few different options and basically based on that went for the majority option. But we did get a flood of requests after that of people who really wanted to be involved but just couldn't make the time. And so we decided that we would have polls that we would send offline. And that's just like a very simple poll done in blanking if it's Microsoft now. It's the purple one that we all use.
Oh, like a Google form.
Google form, thank you.
Okay.
I don't know why I switched to Microsoft. So basically sending that off and getting individuals to fill that in if they choose to, and also just by email as well if there's anything that they feel can't be captured in the form, but by email to please reach out.
Thank you. And then there was one other question that's been put in the chat. Deb perhaps directed at you, I would say. So how do biocurators reach out for some of those newer VCEPs to volunteer? If they sign up through the general curation sign-up approach, would they be randomly assigned or what's their?
Yeah, I think so. Typically, we've had post groups that are accepting volunteers, post it on the website, and then you can go through the training process. If you've already been through the training process, then I would say probably you could reach out to Sahaya. Sahaya, could you put your email into the chat? That's particularly if you're interested in it for hereditary cancer. For other groups, though, I want everyone to know if you go to the website, groups list whether or not they're taking volunteers at that time. I do think that sometimes it's not as updated. So for instance, our group for developing TSC 1 and 2, that's really internal right now. We haven't put that out on the website that we're actively working on that. So if you're interested to be involved in that group, well, I would say come to these calls. But we'd be very happy to have some more members for some of these developing efforts too. Second, I want to say too, so for like TP53, Megan said that they're starting with the application of the second version of specifications. I have noticed that people fall into a couple of camps. One of the camp is do you want to create the specifications or do you want to apply the specifications? So I personally actually am in the applying the specifications group. So I get excited when there's a set of specifications and it's time to curate. So if that's you particularly, yes. So we have some groups that have been around for a while. They do have some biocurators already, but they have a new specification set or an upcoming like chunk of them to apply the specifications to. And that's a great time to get involved in those groups as well.
Thank you. And I saw Christina has put the link to that overview in the chat as well. So thank you for that.
Great. Thank you, Christine.
So we are at time, but thank you to all of our presenters today for that whirlwind tour of everything that's going on in the hereditary cancer clinical domain. And yeah, definitely it seems like there's a number of groups accepting volunteers. So if you're interested or have any colleagues that are, take a look at that webpage that's in the chat and get in touch because we would love to have you join. Thank you, and we'll see you again on the 24th of April. And just another plug to please fill in those 2 surveys that we put in the chat at the start of the meeting. But thank you all.
Thank you.